Hello, my name is Ali Shazwan from Group D11 and this is our video of early strength of sustainable concrete, and we decided to use coconut shell as our material. But first of all, let me introduce my team members. First, we have myself, Muhammad Ali Shazwan bin Mustaqim from Skudai, Johor Bahru. Next, we have Aliana Bila binti Muhammad Zawawi from Sungai Buloh, Selangor. And lastly, we have Muhammad Hafizan bin Syarul from Cahaya Baru, Pasir Gudang, Johor. First, why do we decided to use coconut shell? The idea of using coconut shell as a sustainable replacement in concretes comes when coconut shell is one of the common agricultural waste in Malaysia. According to Mardi, in 2007, Malaysia produced 382 tons of coconut with strong properties. It is suitable to be used in concrete as a sustainable material for replacement. Next, how do we use coconut shell in our concrete mixture? We use coconut shell as a partial replacement for coarse aggregate, which is 10% replacement from the total weight of the coarse aggregate. After filling up the mixed design form, the mass of coconut shell that we needed is around 3.148 kg. The coconut shell also needed to be broken down into small pieces, which is into 20mm to 10mm size of each pieces. Next, what is the advantages of using coconut shells in our concrete mixture? Compared to other agricultural waste, coconut shells has the lowest cellulose content, so it will absorb less moisture. As you know, cellulose fiber absorb water because of its hydrophilic nature. Furthermore, coconut shells makes our concrete lighter. The density of the concrete decreases with an increment of coarse aggregate and coconut shells ratio. For 40% replacement, density decreases about 7.5%. And coconut shell is lighter rather than conventional aggregate like sand and stone, which is heavy. Lastly, coconut shell is a high strength material. High lignin contents make coconut shells more weather resistant. Lignin is an organic polymer and it is a key structure in support tissues of plants. As a mechanical support, it helps with higher strength of the tissues. And physical properties of coconut shell, as we know, is also hard and solid, make it is a suitable replacement for aggregate in our concrete mixture. So, what is the impact on economic and environmental factors if we use coconut shell as our sustainable materials? First, with increment of construction activities, natural materials like stones and river sands are depleting very fast, resulted in scarcity of resources. So there will be less usage in naturally available material if we use coconut shells. Next, coconut shell is a non-biodegradable material, meaning it is not capable of being broken down by the action of living organism. So disposal process is a big problem for agricultural waste like coconut shell. So with the usage in our concrete, it helps with the disposal process of the coconut shells. Lastly, coconut shell is a low cost material. It only costs us 33 cents per kilogram, so we can save money rather than buying conventional cost aggregate that generally cost more in construction activities. First of all, this is how we prepare our materials. For coconut shell, firstly, we need to break down the shell into small pieces measuring 20mm and 10mm each. For this process, we are using hammer to make the pieces smaller. After we done, then we need to dry it under the sun to remove any moisture left on the shell. For the aggregate, sieve the rocks and only use the ones that pass the 20 and 10mm sieve only. And lastly, for the ordinary Portland cement, sieve the cement using 90 micrometer sieve until it reaches desired weight. Next, concrete preparation. First, mix the coarse aggregate, which is rock and coconut shell, cement and fine aggregate, which is sand, in the mixer machine. Turn on the machine and let it mix. Add water slowly and let it mix together for a while. Then, pour the fresh mixed concrete into a wheelbarrow for the next process. Next, clean the mold and apply grease to the inside of the mold. Make sure it is already tightened to ensure no concrete will spill. Then, pour the concrete mix into the mold and compact the mixture using vibration. After it was fully compacted, smoothen the surface by using scraper so no honeycomb will form later. Then, leave the mold filled with concrete in a room temperature for 24 hours. After 24 hours, remove the mold carefully so the concrete will not broken. Label the concrete cube and submerge it in a water tank for the curing process. Next, to know the workability of fresh concrete, there will be two tests that will be conducted. First, the slump test. After compacting each layer for 25 times, carefully pull the slump cone in a vertically upward motion. Measure the slump of concrete with a steel ruler and determine the slump of the concrete. In our cases, our slump type is shear slump. Next, the compacting factor test. After pouring the concrete mix in the upper hopper, open the hopper and let the mix fall into the lower hopper. Repeat the process and the weight of the cylinder is measured. Fill the cylinder again and compact it using tamping rod for 25 times. In our case, the compaction factor is 0.98, meaning the workability of our concrete is high. The compressive strength test. Before starting the test, air-dry the specimen after taking it out from the curing tank. Record the weight and its dimension for filling in the data needed in the computer. Place the specimen centrally in the machine and start the test. Record the maximum load and compressive strength. This is our concrete strength after 28 days. The maximum load of our concrete is 204.5 kN, while the maximum compressive strength of our concrete is 9.09 MPa. Now, we can know the properties of our concrete after using a sustainable material as a replacement. That's all from us. Hope you enjoy this video. Thank you.